In the present video, I will be explaining how to make a hypothesis test for the proportion. This will be a one-tailed test, and I will be using the p-value approach. I will be explaining this with an example. Assume that the company claims that the proportion of dissatisfied customers is less than 0.10. To test this, a random sample of n equal to 100 customers is selected and 12 are dissatisfied, using a 0.05 significance level to make this hypothesis test. So of course, the first thing to do is state the hypothesis. And we have here that the company claims that the proportion of dissatisfied customers is less than 0.10. So this is one hypothesis. And because this hypothesis doesn't have an equal signs, this will be an alternative hypothesis. So let's type this as an alternative hypothesis. So the proportion is less than 0.10. And this is the research hypothesis. This alternative hypothesis in this case is the one that the researchers want to know. Opposite to this, opposite to p less than 0.10, we have p greater or equal than 0.10. So this will be the null hypothesis. And this null hypothesis will be just considering that p equals 0.10. So I'm going to use p equal to 0.10. This is the thing that I'm going to consider true, and I'm going to use p, this value of p, in the formula of the test statistics. If we have a hypothesis test for the proportion, the test statistics is the z distribution, is the normal distribution. And because in this case we are going to use the p-value approach, we are going to start immediately computing the test statistics. So the test statistics is the z-value, is the z statistics. So use here z equal, and we know that this is sample proportion minus the proportion divided by the square root of the proportion multiplied by 1 minus the proportion divided by n. And this value of the proportion that appears 3 times is the value of the proportion that I'm going to consider as true. So that the proportion is equal to 0.10, the one that appears in the null hypothesis. The value for the sample proportion will be the one computed from the sample. And we know that from a sample of n equal to 100 customers, 12 are dissatisfied. So we compute this, and we have that the formula for the sample proportion will be the number of successes divided by the total number of elements in the sample. So it will be sample proportion equal the number of successes is this x divided by the sample size. And when I say successes, I'm saying success in quotation, because in this case, to be success is to be dissatisfied. So we are going to check how many dissatisfied customers. There are 12. 12 divided by 200, it will be 0.06. So that will be the value of p bar here, and then just make a substitution. P bar is equal 0.06, p equals 0.10. Obviously 1 minus p will be 0.9, n is equal to 100, the sample size. So we make the substitution, we use a calculator, compute this, 0.06 minus 0.1 divided by a square root of 0.1 times 0.9 over 200. I put this in brackets in my calculator, press equal, and I get negative 1.886. Now that we have this, now we are going to use the fact that we are using the p-value approach. Remember, the p-value is the smallest alpha needed to reject the null hypothesis. So, in the normal distribution, you know that 0 is in the middle, this negative 1.886, there will be a value here in the negative part of the distribution. And if you see this area here, if this area were alpha, then we're going to be rejecting. And whatever area bigger than this will makes that this z value will be in the rejection region. So for that reason, this area to the left of this value will be the p-value. This will be the smallest area to reject the null hypothesis. Any other area bigger than this will make that this arrow here will be in the rejection area. So to compute the p-value in a left tail test, because this is a left tail test, anytime that we have an alternative hypothesis with a less than in it, this will be a left tail test. So anytime in a left tail test, the p-value will be the area exactly below, exactly at the left of the z value that we computed. So let's compute this area. You can use a table, find an area that is below negative 1.89, or use Excel. I'm going to be using Excel, so I'm going to open Excel, and in whatever cell of Excel, I'm going to type normal standard distribution of negative 1.886. So in Excel, in whatever cell of Excel, I will be typing equal normal standard distribution of negative 1.886, comma 1, and cross the bracket. So you need to type this one to tell Excel that this is a cumulative distribution. So that means that you are going to compute all the area until that number. And don't forget to use the equal signs at the beginning. So now that you have this, press enter in Excel, and Excel is going to give you this area, and this area is the p-value. So I compute the area, and I found that the area is 0.0296. This one will be the p-value, the area here. So this p-value will be 0.0296. As soon as I have the p-value, I will be able to make a decision. And the decision will be, in this case, because this p-value is smaller than the level of significance, that is 0.05, this p-value is a little lower than 0.03. Yes, this is the level of significance is 0.05. So we reject the null hypothesis because the p-value is smaller than the level of significance. So because the p-value is 0.0296, is lower than the significance level 0.05, we reject the null hypothesis and accept the company claim. The company claim was the alternative hypothesis. Yeah? So we reject this. There is enough statistical evidence to reject the null hypothesis and accept the claim of the company, that is that the proportion of dissatisfied customer is less than 10%. Okay, this is an example of a use of the p-value approach for solving a hypothesis test for the proportion. I hope you have found this useful. Thank you.